Welcome back, class. Today we're going to be talking about early radio. Think about this. Barely 100 years ago, the fastest way to get a message from a ship at sea to someone on shore was by carrier pigeon. Today we have instantaneous worldwide communication through satellites orbiting the Earth, connecting us through a growing number of different electronic gadgets, from computers to cell phones to iPads, etc. The original insight that made all of this possible took place in 1877, when a British scientist postulated that electrical fields and magnetic waves can couple together to form electromagnetic waves. He was James Clerk Maxwell, an English scientist. He noticed that electrical fields and magnetic fields could couple together to form electromagnetic waves. The electrical field, like the static that forms when you rub your feet on carpet, and a magnetic field, like those around a magnet, can't go anywhere by themselves. But Maxwell deduced that changing magnetic field would induce changing electric field and vice versa. Unlike static field, a wave cannot exist unless it's moving. Maxwell postulated that once created, an electromagnetic wave would continue on forever unless matter absorbed it. That was all theoretical. No one had actually demonstrated that this could actually work. That's where Heinrich Rudolf Hertz comes in. You may recognize the name. Hertz today refers to computer chip speeds, as in megahertz, gigahertz, etc. Hertz was a German physicist born in 1857. He clarified and expanded Maxwell's electromagnetic theory by building an apparatus to produce and detect electromagnetic waves. Hertz positioned the oscillator about 12 meters from a zinc reflecting plate to produce standing waves. Using the ring detector, he recorded how the magnitude and waves component direction vary. Hertz measured Maxwell's waves and demonstrated that the velocity of radio waves was equal to the velocity of light. Hertz also found that radio waves could be transmitted through some types of materials and were reflected by others, leading in the distant future to radar. Hertz did not see any practical importance to his demonstration. He said, "It's of no use whatsoever. This is just an experiment that proves Maestro Maxwell was right. We have these mysterious electromagnetic waves that we cannot see with the naked eye, but they are there." Asked about the ramifications of his discoveries, Hertz replied, "Nothing, I guess." Related the names of Maxwell and Hertz thus far, but scientists and engineers all over the world were involved in experiments with wireless communication. Claims to be the first are made by Spain, Germany, and Russia, to mention only three. So, with the invention process, scientists postulate a theory, engineers invent an apparatus that shows the theory works, an entrepreneur figures out how to make money on the apparatus, and with remarkable consistency, the scientists and engineers rarely make much money for their work. So, let's talk about this inventor. The roles of entrepreneur and inventor sometimes overlap. Guglielmo Marconi was both an engineer and entrepreneur who turned wireless communication into a moneymaker. Marconi, who was born in 1874, the Italian inventor best known for his development of a radio telegraph system. Marconi built his equipment in the attic of his home at the Villa Grifone in Pontecchio, Italy. His family was very well off. His goal was to use radio waves to create a practical system of wireless telegraphy. Others had tried and failed. Marconi wanted to succeed. He didn't discover any new and revolutionary principles, but he improved the way they were used. His oscillator, or spark-producing transmitter, was similar to Hertz's. He added a telegraph key to send a short and a long pulse, corresponding to the dots and dashes of Morse code, and a telegraph receiver, which recorded the Morse code dots and dashes onto a roll of paper tape. He had limited success in transmitting any distance until he moved his experimentation outdoors, as you can see here in this photograph. After increasing the length of the transmitter and receiver antennas, arranging them vertically and making sure they touched the ground, the range increased significantly. Nobody in Italy was interested at this time, and in 1896, at the age of 21, Marconi traveled to London, England with his mother. Like most European aristocracy, they both spoke English fluently. The chief electrical engineer of the British Post Office sponsored a series of demonstrations for the British government. Marconi transmitted Morse code signals over a distance of about 3.7 miles. On May 13, 1897, Marconi sent the first ever wireless communication over open sea from South Wales to the Somerset coast, about 10 miles away. Marconi began to receive international attention. In the fall of 1899, he sailed to the United States at the invitation of the New York Herald newspaper to cover America's Cup races off of Sandy Hook, New Jersey. In 1901, Marconi claimed to have sent a signal completely across the Atlantic. It was a key business claim that would allow him to compete commercially with transatlantic telegraph cables. Marconi began regular transatlantic radio telegraph service in October of 1907, but even after the company struggled for many years to provide reliable communication. Keep in mind, Marconi was only broadcasting dots and dashes. He was a long way from radio transmission of actual sounds. So here you can see what it might have looked like in those days when he built those high-powered stations on both sides of the Atlantic to communicate with ships at sea in competition with other inventors. So let's move on to another famous inventor. You might know Nikola Tesla's name from the Tesla cars, but Nikola Tesla publicly demonstrated the principles of radio and transmitted long-distance signals in 1893. He holds the U.S. patent for the invention of radio, as defined as wireless transmission of data.
Before we go,
remember, Tesla, Marconi, and others were only broadcasting dots and dashes. They were a long way from radio transmission of music or voices. Next, I want to play you the opening portion of a documentary by Ken Burns called Empire of the Air, about the origins of radio.
Intercontinental Radio News. And we'll have our commentator give you a word picture of the scene as soon as he can reach there from Princeton.
Listen at 6 o'clock tonight over the station WEAF, NBC in New York.
Stopping all wings to LO, London. By land wire from there to 566.
Out of the fog, out of the night, and into his American adventures comes Bulldog Drummond.
Sound itself attracts. Ask any eavesdropper. Sound is the first stirring of the infant. He hears sounds, he puts them together, and they cohere. Sounds have a romance. The sound of a cricket at night to establish mood in a radio drama. Very simple effect. The sound of thunder, the sound of rain. There is no sound on the moon because it takes air to support it. The vibrations of air create the sound. And radio was a medium which employed that magic.
Come on, men. We're gaining on them. They've seen us, Tom. Right, fellas.
Tell me, Mr. Moody, what are your feelings about the radio?
I don't hold with it, Bub.
Displeases you?
I don't hold with furniture that talks.
There's a great sensational wonder today, we know. Everyone is talking and fooling with radio. It's a wireless telephone. I just bought one of my own. Now I sit at home alone and hear them dish the dirt. But all that I can hear is
Radio made America a land of listeners.
sounds like wildcat hisses, but it's boys and misses making silly wishes.
It entertained and educated, angered and delighted Americans of every kind and age and class.
Buzzing in my ear is traveling men and females, lonesome wives and females, spoon by ducks and dashes, making wireless mashes.
It taught them new ways to dance and talk and think.
Filled with love tales by the score, and maybe
It brought the world into their living rooms and sold them things they hadn't known they wanted.